Hey everyone, welcome to part 2 of the DevOps Interview Questions and Answers. I'm Sonal Mittal and I'm trainer at StarAgile. I conduct the various DevOps batches and trainings on tools like Kubernetes, Ansible, Docker, Terraform, Prometheus, Grafana, and CI/CD tools like Jenkins and GitHub Actions. I welcome you all on this session on the DevOps Interview Questions. Now, if you have not seen the part 1, please go ahead and check out the video. We have already completed a lot of questions on DevOps in our part 1. Now, please go through that so you are completely prepared with respect to the interview questions on DevOps. Now, let us get started with the rest of the questions. As part of this, we have already completed questions related to DevOps lifecycle, configuration management, what is infrastructure as a code tool. Now, in this particular part, we shall be discussing in detail about some of the important tools, starting with version control tool, Git and GitHub. So the first question includes over here is, what is a GitHub repository? Now, learning a tool in theory is very easy, but let us put effort on learning it more practically. That will help you to back up your answers while giving an interview. So what is a repository? First and foremost, understand the term repository. Repository is a location, is like a folder where you take backup of your files, where you store versions of your file. That's a repository. Now, in Git, there are two types of repositories, local and remote. Repositories that you create in your local machine, like, for example, this folder in which I may create a file. Let's say I create a document with the name index1.html. Now, this is a folder where I'm storing a file. Now, I will create a repository in this folder, in my project folder, where I'm going to take backup of these files or take backup of or store the versions of the changes that I'm going to do on this file. So that's a local repository. But when you open a repository which is over the internet that everybody can access, like, for example, I share this repository with you. Now, anybody can access this code. I share this repository link. This is a public repository. So it's again a location over the internet where you're maintaining your files, your data, and that can be accessed by everyone over the internet. So that's a remote repository or a central repository. So when you work with a version control tool, you work with two types of tools, local version control engine, which is Git, and a remote repository, which is GitHub or GitLab or Bitbucket. As we proceed, you will see the difference between GitHub and GitLab. What is the difference between Bitbucket and GitHub? So it's good to know questions. Now, I'll demonstrate to you how to create a local repository. So this is a folder in which you can see I have got a single file. Now, I want to ensure I maintain the versions of each of these files. So I will execute the first git command, which is git init. So git init is a command which initializes git on this folder, telling us that now any file, any change you do in this folder is tracked by Git. Git will ensure it is version control. Initialize Git on it. So that is when you see the error or you see the message, sorry, not error, that initialized an empty Git repository, isn't it? So here you will see the creation of a .git folder. So if I take you here, you can see a .git folder. So that is your local repository, okay, which will ensure all the versions of this file. Now, creation of remote repository is the same and very easy. You may use a remote server, like let's say we are using GitHub. On GitHub, you can click on this plus sign or on this new button to create a new repository. Let's say create a repository, my project versions 06. Okay, so you can give a repository name which is available and then go ahead and create it. In remote repositories, you can create a public repository which is visible to everyone. Everyone can see the files, but they cannot commit into them. They cannot make changes into it, but they can see the files. If you choose private, then nobody can see the repository. You can give permissions to the users who can access your repository. So I'll create a public repository for you. Now, a public repository with the name My Project version 06 has been created. In this repository right now, I don't have any files. So we can push the files from the local to the remote, right? So here, just sticking to the question of what is a repository? A repository is a location where we store our files and the changes that we do to the repositories are local or remote. Locally, they are created in your local machine and where you maintain a .git folder, a remote repository which is created over the internet, right? So that's your remote repository. Now, as we proceed, we will add files into the repository or we will push the data into the repo. Now, I'll proceed with the next question. Now, what is the concept of branching in Git? A branching is something which you start working from the very beginning when you start creating or committing into a local repository. Branches allows a developer to work simultaneously on various tasks at the same time, or as I use the term, simultaneous. In the real time, a person may be working on various activities like development or testing activities or activities related to release, activities related to fixing the issues. So you cannot do the changes on a single branch all the time. So branching allows us to segregate our task in different sections, or we call them as branches, allowing us to work parallelly onto our repository. So branching is a concept that starts from the local repository and is pushed into the remote repository. So before we see what are the different types of branches and how do you merge the branches in Git, I will explain it to you how to create a. So the next question, which is cherry pick command, rebasing, merging and rebasing. So I'll cover all of these questions as part of the demo that I'm going to show you. First, let us see what is branching. Now, once we create a repository, you will execute the command git status, which shows whether the file that we have created is tracked by Git or not, isn't it? So here index1.html file is not tracked by Git yet. It is an untracked file. So you must know the basic workflow of Git is to add the files to the staging area using the git add command. We add the files to the staging area. Once the files are now staged, the color you can see has changed to green. So this is when Git runs hashing algorithms to convert the staged file into a snapshot. Git local repository stores the files as a snapshot. Okay, so we will go ahead and now commit. So you use the git commit command, added an index1.html. Now, once the file goes into the local repository, there is a commit ID which has been generated with the message that you have given. Now, the file is new. There are no contents inside the file, hence 0 insertions, right? You can see the files that have been staged or added to the local repository via the command git ls. So whenever we perform a commit onto a local repository, we always commit it on a branch. So knowingly or unknowingly from the very beginning, you are working on a branch called as a master branch. You can see over here, git log command gives you the log that one commit has been created. This is also called as a hash. The first 7 characters of commit ID, and head represents that it is the most recent commit ID. Master is the name of the branch. You can execute the command git branch to see that you have a branch created. So assume that this is your repository. In the repository, you have got a master branch where your files are present currently. Now you want these files are the final code. Now you want to make some changes or you want to do some testing on it. So you will not want to make changes. You will not want to make changes on the code that is already working. So you would want to make a copy of it. So Git allows you to create another branch, let's say a feature branch, which is a copy of the master branch. Same files are available on which you can add more changes. Like let's say I add a login file, right? Once this branch or changes have been completed on the files, you can then perform a merge command. So a branching follows the merge operation. Branching is a process where you create it on the local repository. A branch copies or is created from another branch, like by default a master branch. A branch is a copy of your master branch. A branch has the same files as that of master branch. A branch allows you to simultaneously work on various activities. A branch allows you to make changes on the code that is working without impacting the final code which is on the master branch. You can also rename this branch as a main branch. Any name is okay. The main branch and the master branch are the branches where you have the final code, the code that goes to the next environment, maybe a test environment or maybe a production environment. So branches are where you are like your playground, where you have a copy of your actual code and you make changes to it. Once you have tested it thoroughly, you will go ahead and you will merge it to the main branch, the final. So in real time, we have different branching strategies and different branch names like a feature branch, a release branch, a development branch, a hotfix branch, right? So what is a feature branch? Whenever we want to do or create or develop a new feature, the developers will create a feature branch. Whenever a new development activity has to take place on the existing code, we will create a feature branch. Once the feature are completed and set of features are ready to be released to the next environment, you create a release branch. A release branch has all the dev files that are to be released to the next environment, as well as your release document that and the review documents of the code. So in the release phase, we review the code, we fix the code, but no new feature is created in the release. No new code is added in the, or new feature is not developed in the release. Only the existing code is reviewed, tested, any changes of the existing code are made, release documents are attached, and this is then merged with the final branch. You also have a hotfix branch, a branch where once the code goes into production environment, if there are any issues, so from the master branch, you create a hotfix branch to immediately fix the production issue. See the name hotfix, a fix that is to be given immediately into the production environment. This fix is then merged with the development phase or development branch and the master. Now, before going deep diving into different types of branches, first let us learn how to create a branch. So to create a branch, it is very simple. There is a command called as git branch. And the name of the branch, let's say a feature. You can give a name, any name to the branch. Let's say feature. Let's say login is the feature. So I'm giving the name as feature branch. You can give the name as release branch, hotfix branch, test branch, anything. This will create a branch. Once the branch is ready, we switch to the branch. Or you can use a single command, git checkout -b feature login. Okay. So here checkout is a command which will create a B here stands for a branch. It will create a branch feature login, and it will also switch to the branch so that you can work on that particular. Please see. I press enter. So we have created a new branch feature and we are also switched to that branch. A branch is created based on the master branch. So master is the base of your new branch. You can see your branches. You have got 2 branches and the star represents currently you are on the feature. On a branch, you will right now see the same file. Sorry. On this branch, you will still see the same index file. You can add changes to this. You can open the file. Let me open it on the folder and we'll add some changes. Added new changes on the feature. And I'll save this one. You can see the status of the Git. It says you are on the feature branch where you are making modifications on this file. Okay. Now, you may go ahead and rename if you want as an index1.html. But right now, we are not going deep into changing the names. we can just assume that there are modifications on this file, or you can execute the command to rename. Okay. It's okay to be a test file here. 1.html.txt, index1.ht. Okay, this is also there, but I think the mv command doesn't work on the command prompt. You can open it on a PowerShell to run the Linux commands in Windows machine. Or you can go ahead and change it directly on the folder. So here we can run the Linux command, index1.html.txt to be just index1.ht. Okay, this is also fine. Okay, now that's great. So let us execute git status command, and we see that we have renamed this file, so that goes as deleted file, and there is an untracked new file index1. Okay, with all of these changes are happening on the feature branch. Now you may add the changes, and Git basically when you make or you are renaming a file, so that goes as a deleted file, and Git will track the new changes, the new file with the new name. However, this doesn't mean that there are two files created in the folder. You can see there is a single file inside the folder. It is just the name that has been changed. So we want to send that change to the name, even to the local repository. Hence, we will go ahead and git add, and we will do a git commit. Okay. Now this is being done on the branch feature. Okay. So here two changes have been done. One has been deleted. This change of the file name has been deleted, and index1 file has been created. You can see the status. Now the working tree has to be clean. The number of files in the local repository are only index1.html file, right? Now these changes have occurred where? These changes have occurred on your branch called as feature branch. Okay. Now similarly, you can switch to a branch, that is checkout is the command. If you want to go back to the master, git checkout master, if you want to go back to the master branch. Okay. Now you will see that the changes that you have done on the feature branch are not available on your master branch. The changes that we have done, renaming the file, adding the content to the file, are not there on the master branch. They are there only in the feature. So if you want, once your branch is completed, the changes you've done to the branch is completed, you can merge those changes into the master so that both the branches have the same changes. And then we delete the branch. Why should we have two branches with the same? So what developers do is they create master branch. From the master, they create a child branch or feature branch. They do all the changes over here. They perform the testing over here. Once everything is working fine, they merge it to the master branch where the final code is present. And then delete the feature branch if not required. So I'm going to go ahead and do that. Merge command, git merge. So a merge is the command which merges the changes from a source branch. This is my source branch, feature minus. So whatever changes that are not there on the master branch, but are present in the feature branch are called as, are the new changes on the feature, but are not there on the master, have to be merged. So I'm already on the master branch. So always remember to switch to the branch. Switch to the branch where you want to do merging. I have switched. You can see I switched to the master branch. On the master branch, I'm taking the source feature branch and merging it to the destination master. Okay, so you can see this has been removed and index1 file has been added. Plus there is one line which has been added in the, you can see here. Now, both the branches have the same file. You can now delete this branch because we no longer want it. The task of feature creation has been completed and we have merged it with the master branch. If in future I want to do any new changes, I'll create a new branch. So the development branch or the feature branch can be removed using the git command branch -d, delete. Git delete the branch feature. It deletes this branch. Okay. Now you will not be able to see the branch. You have a single branch only, but the changes are already there in the master. Sorry. Okay. All right. So this is about your branching and merging. Similarly, you can create a release branch from the master branch or dev branch. You can create a hotfix branches. Right. Now, so this completes your branch. Now, there is also another command of merging, which is a cherry pick command. Okay. So when we talk about the merging, let me use the PowerShell here, which is much better. Git status. And you can see the branch which you are on, master branch. Now, please note here, if you create a branch, on the branch, we can do multiple changes. When I execute the git merge command, all the commits will be merged into the feature branch or onto the master branch. Let us see this use case. I am going to again create a branch using the checkout. And let's call the branch as a feature one branch. Okay. Git checkout -b flag. All right. So we are on the feature one branch. Git status. It will show you that you are on the feature one branch. You can execute git branch command. Okay. Now, after this is done, on the feature branch, let us create some files. Let's say file one. So I will go ahead and I'll create it directly on the folder. Sure. So let's create some text files here. Index 2. First, I created index 2 file. Right? Now you see the status, it's a new file. Let us add the file to the local repository, to the first staging area. You will see it is staged and the color is in green color. Let us commit on the branch feature one. Okay. We have got a new commit on the feature one branch, which is not there on the master. Okay. Now I'll add one more file. Again, add it and commit. Index. Once this is completed, we will see here we have got new commit. Okay. Now, if you will see, there are many commits available. Now, if you will switch to the master branch and we execute the git merge command like we did previously. So switch to the master branch, git checkout master, switching to the master branch. Always switch to the branch where you want to do the merge. We switch to the master branch. Once on the master branch, we will execute the merge. If I say git merge, feature one to master. So all the new commits. Now see, observe this log history. When you see master, that means still here, all the commits are on the master. These two commits are not there on the master. These are there only on the feature one. Now, if I execute git merge, all these two commits will get added to the master. But let's say I don't want to add both the commits. I want to choose. So that hence the term cherry pick. I want to pick a specific commit ID and then merge to the master. So I will use the command cherry pick. Now there are various ways to do it. You can also use the squash operation. You can also stage your changes and then switch to the master branch and then commit on the master branch the changes that you want. Okay, but if you, let's say there are many commits, you want to merge only a specific commit, then you use cherry pick. Git cherry pick, you can say. And you will give the command. Let's say you'll give this commit ID. Okay. Only this commit ID changes. Whatever changes we did as part of this commit ID will go ahead and get merged on the master branch by creating a new commit ID. Please see. So it cherry pick command creates a new commit ID on the master branch. We have picked specific changes from this commit, or we have picked this specific change and merged on the master, which was the index 2. If you will see the log, see here, this is the new commit. Okay. All right. Similarly, you can again pick up the first commit if you want, the most recent, or you can go ahead and do the merge commit. Git merge feature 1 master. So all the commits that are not on the master branch will get merged. Index 3 file is now. Okay. So you can see all the 3 files are there on the master. You can now delete the branch feature 1. Git branch -d feature. Why to have 2 branches with the same content? You can delete the branch. You can delete the branch even if you have not merged. Just use the operation capital D minus capital D. Then you can delete a branch even if it is not merged with the master branch. Great. So that was your cherry pick command, which is used to apply the changes from specific commit to one branch or another branch. It is not merging the commit ID. It is just picking those specific changes of a commit and applying them on a branch. It is useful when you want to selectively choose certain changes and move to a branch. Whereas in merge, we merge the changes as well as the commits go to the local repository, to the master branch. So that is your cherry pick command. Now, in addition to merging cherry pick, we also have a strategy called as a rebase merging strategy. So let us try to understand what is rebasing, which is a little advanced topic on Git. Let's try to understand with the help of this diagram. Let me take a branching example. Okay. So I'm sure you're able to see my screen. Pay attention. So far we have learned about a master branch, and from the master branch, we create a feature branch. So let us say the master branch had the commit C1 and C2. When I created a feature branch based upon master, feature branch also gets the commit C1 and C2, right? These 2 commits we will get. Now, on the master branch, we create a new commit that is making some changes in the file, or creating a new file, we create a new commit. On the feature branch, we switch and we create more commit IDs like C4 and C5. The regular merging strategy is on the feature branch. So you can merge on any branch. It doesn't mean you have to merge only on master. No, you can merge on any of the branches. You can merge on the master. You can merge on the feature branch. On the feature branch, if I am merging, I'm performing the git merge operation. The new commit ID that is not on the feature. So you're merging something which you don't have it. That's the force you're applying. That is a merge you're applying. So the commit or the changes that are not on the feature, Git will try to merge it with the feature by appending the new commits in the beginning. So feature branch commits remain as it is. The new commits of the master get appended on the feature branch in the very beginning. So you integrate all the new commits on the master and merge it on the feature branch, and they get appended in the top, on the top as the most recent commit. I'll show you this before we move to rebase. So we'll perform these steps. First, we already have a master branch with some commits. You can remove the commits using the git reset command. You must be knowing that. Git log one line. So I'll just remove the desired commits that I don't want. So let's say I just want only this one single commit should be. So if I want to reset my commit history and remove the changes that I have done, I will use the git reset command. So that's a separate discussion that we can do later on, a reset command. A hard operation will delete all the commits before 2C6, before this. Whatever commits I have, all will get deleted, changes will get deleted permanently. It's a destructive command, don't use it. Just to show you the next use case, I am using this. However, we don't prefer using it on our actual project. All right, so I just got a single commit to easily explain you what is merging and rebasing and the difference between merge and rebase. So let's go step by step. I will first see I have a branch master. On the master branch, I have a single commit right now. I have a single commit. From this master branch, let us create a feature. So git branch. I'm not switching to the branch. I'm just creating the branch. Feature one. Feature one branch. So git branch will just create a branch. It will not switch to the branch. Checkout minus B will switch to the branch. Now here I have got only the master branch. I am on the master branch. We have the feature. Now going ahead with the diagram. On the master branch, create a new commit. Switch to the feature branch, create two new commits. Let's see. On the master branch, I shall create a new commit. So I'll create a new file. Let's say file on the master. Okay, I'm creating a new. So git status, you can see we have got a file on the master branch. Let's add the file. Once the file is added, git commit minus -n. I'll add a message done on the master branch so that we can refer and understand who performed the commit and why we performed the commit. So here we have got a master commit on the master. Great. Now, as part of the diagram, we switch to the feature branch and create two more commits on it. Great. So let's do a git checkout command, which will switch to the branch feature. You can see the status. You are on the feature one. Let's create some file. File 2 on the, let me just quickly rename it. File 2 feature. Okay. Similarly, we will do a git add here and commit. Right? I'll create one more commit, probably making changes into this file. Git status. Any modifications are there can directly be committed into the local repository using the git commit command, git commit -a -m. Now, if you will see the log of the feature branch, it has got two new commits which are not there on the master. Master branch has got one commit which is not there on the feature. Now, the first operation that we want to see is merging, which we have already seen. Previously, the feature branch was merged to master. It was the source was feature and the destination was master. But this time, I want to merge master branch just to show you any branch can merge into another. So master branch commit should merge to feature. So first switch to the branch. First switch to the branch where you want to do merging. We're already switched to the feature branch. Now I shall do a merge. Merge master to feature. So there is one commit on the master, it comes to the feature. Now I want to show you that merging is a non-linear workflow. Non-linear, that means the commit gets appended on the top of the most recent commit. Right? Merge is made as a recursive strategy where the master file and the commit comes and get appended as the topmost commit. You can see. Okay. So these you can see over here, the file is now available. Okay, master file is now available. All right. This is your merging strategy. Now, in addition to this, you also have a rebase command. Git rebase. Now, in rebasing, what happens is it's a linear workflow. In rebase, we'll keep the diagram. In rebase, we reorganize the base of the feature. So first, all the commits, 1, 2, 3, all the 3 commits of the master will be there. And then all the commits of the feature will be present. New commits. So please pay attention. Rebasing is a merging strategy where you reorganize the base of your feature branch. So first, this is the base of master. Feature branch got created on the same commit. There was a new commit on the master. There were some new commits on the feature, right? C4 and C5. But if I execute a rebase command instead of executing the command of merging, instead of merging, you execute a rebase. It is also a merging strategy. But in case of rebase merging strategy, we reorganize the base. So what is the base of the feature branch? The master branch commit. So all the commits, new and old, all the commits of the master branch are packed together and applied as a patch on the feature. So first, all the commits of the master will be there. Then the new commits of the feature will be. So this is like rebasing, reorganizing the base of your feature. So let's try to perform this operation. I'm going to switch to master branch. And I'm going to delete the commits. I'm going to first delete the branch, capital D. You can give capital D if you have a non-merged branch. Like I have not merged the changes from feature branch to the master branch. So I'm going to just delete them. Deleted the feature branch. If you use small d, if the changes have been merged from a feature branch to master, capital D if you have a non-merged branch. Non-merged branch. Now, let's go ahead and see the changes. Okay. I have a file on the master. Okay, I've got 2 commits on the master. We can proceed again. I have 2 commits C1 and C2. C1 and C2 on the master branch. C1, C2 is just a reference. They are just a reference, a dummy reference. Okay, but these are the actual commit IDs which are there on your master. We shall check out, we should create a branch. Let's say rebase branch or feature branch is also. RB branch, I'm giving the name. Okay, rebase, RB stands for rebasing. Now, I've got 2 branches, master and RB branch. Now the RB branch, the rebase branch also will have the 2 commits. Now we'll create a new commit on the master by creating a new file. Or you may go ahead and do a change on it. Or let's create a new file. Okay. We have an already existing branch which has the 2 commits. Now we will add and create a new commit. Okay. Let's refer to it as C3. So we have created a C3 commit onto the, you can see the log. Right? We have got the C3 commit. Now we have got 3 commits here, but the 3rd commit is not there on the base branch, or sorry, on the feature branch or the rebase branch. Now we'll check out to this branch. On this branch, we will create 2 new commits. Okay. So I shall create 2 more branches here. 2 more files here, not branches. 2 more files. RB file 1. I'll create a new commit. C3, C4 commit. Again, I'll create one more file. It could also be a change. Doesn't mean it has to be a file. It could also be a change in the existing file. That's okay. Add, and we will commit C4. So I've got C3 commit on the master, C4 and C5 commit on the feature branch. You can see the log. Okay. Now, if I do a merging, in case of merging, the C3 commit comes and sits on the top. Okay. Because that's where we have done the merge. But if I do a rebase, git rebase master, give the rebasing is always done on the feature branch. Rebasing is never done on the master branch because that is a base branch. You will never do one. So rebase is something which is done on the master branch only. And that is done on the feature branch by taking the base branch, which is generally the master branch or the main branch, okay, or the dev branch. So rebase, reorganize the base by taking all the commits of the master, place them first, and then place the feature branch. So please see, successfully rebased and updated the reference. So it's a linear workflow you can see. So first C3, then C4 and C5 is all the commits of the master. Now the advantage of rebasing is, so whenever if you are the only one working on your repository and you wish to have a very, very clean commit history where you have a set of commits of the master, then set of commits of the feature branch in a much organized way, then you go with the rebase merging strategy. But for audit purpose and for clarity, for as purpose, in real time, we always prefer doing a merging. So in that case, we are merging the commits in the same way as they have occurred onto the branches. But whenever we want to avoid conflicts, that's my next question also. What are conflicts on Git? So I'll talk about it. So whenever we want to avoid conflicts, rebasing merging strategy help us to avoid conflicts also on the branches. That's another advantage of rebase. So that completes a rebase operation. It is used to move a combination of commits from the master branch to the feature branch. It maintains a linear commit history. Apply changes from one branch to the another branch. So this is applies changes from the base branch to the feature branch. Okay. So we have seen the explanation of the rebase. And you are now clear between what is rebasing and what is merging. Merging combines the changes of the any branch onto another branch. It doesn't change the base of the feature branch. And it is merging can be done on any branch. Whereas the rebase reorganizes the base of your feature branch. It's always applied on the feature branch. You never rebase a master branch. Okay. All right. So I hope there is a clarity on Git merging and Git rebasing. Now let's talk about what is Git Stash. Before that, let us see if there is a question about squashing. So let's talk about squashing first, then we'll come back to stash. Squash. So since we're talking about the concept of branching and we're discussing the questions on branching and merging, so squashing also comes part of it. So there are times when you do multiple commits onto a branch. On a branch, there will be many commits that you have done. So you may want to squash all of them into a single commit ID. Then squashing comes into picture. If you want, you're on a particular branch, you have done many changes and you want to merge them, rebase. Again, rebase command will come into picture to perform squashing. You want to merge them onto a feature branch or on another branch. Then you can use the squashing concept. Let me explain you how squashing works with the help of rebase operation. So what we'll do is prepare the commands for you. So squash the commit IDs with the help of the rebase command. One concept of rebase is merging the commits of the master first. In addition to this, we may have multiple small changes on a branch and we may have committed them separately. So we will want to commit them in a single commit ID. So in that case, rebase command can be used to squash the changes into a single commit ID. Let's go ahead and do that. Okay. So let's say I go on, I'm already on the branch. I'm already on the branch feature. Okay. On this branch, let's say we have already got many commits. I do more commits on it. Let's say I open this file. I add new changes, and intentionally some typos are available over here. We do these changes. Even with the typos, I committed in the and added the changes and committed it into the repository. Added change one. Okay. But I realized there were some errors onto it, so I removed the dot. So for a small change, every small change, I'm committing into the repository. Just even if I remove the dot, I'm making a commit into the repo. Let's say there is a typo. So I save the changes and committed into the typo error, committed into the repository. Again, probably add a new line. And we are doing it on the same file. It could be a different file, doesn't matter, but it is just that multiple changes are happening. Now, if you see my commit history will be very, very long. Like this, you may end up having a lot of commits onto your repository. Even for smaller changes, you are having new commits. So what Git tells is you can squash all of these commits into a single commit ID. So these are same changes on the same file. These are multiple changes, sorry, not same changes. Multiple changes on the same file, which have been committed separately. So they are just making my commit history very lengthy. So I can use a command called as rebase again. Goes in an interactive mode. I stands for interactive, and I want to squash all the commits that are there before this commit ID. Whatever commits are there, I want to squash. Before this A3, whatever commits are there, I want to squash it into let's say this commit. Into this commit ID, I want to squash all the changes. Or into this commit ID, I want to squash all the changes. You can choose any operation. So first we will choose A3. So before this, whatever commits are there, I want to squash them into a single commit. Okay. So we will use a git rebase -i command. So we have created multiple small changes on the branch, and we have committed them separately. We want to list new commits on our branch. Now we will choose a set of commits and squash the changes into a single commit ID. That is above it. So please see. So all these changes that we have will get committed into a single commit ID that is above it. In this commit ID, it will get squashed together. Please watch. What I'll do is I'll make a copy of the commits that we have right now, and I will place it here. Okay. Now let us open. When you execute the rebase in the interactive mode, it will open an editor for you. In the editor, it is asking you what are the commits that you want to squash. So leave the first one. Okay, use this commit. So pick here stands for use this commit. So use this commit. That is the very first commit. And inside this commit, squash all of them. So for squashing, you will use the operation squash. Okay. So I'll change the rest of them as squash. I'll press I to insert. And I'm going to change it to squash. So squash is like combining multiple commits into a single commit. So the first one remains the main commit where we are going to merge other commits into it. Squash. Okay. Use the commit, but meld it into the previous commit. So use this commit, from here it will start. Meld it into the previous commit. Use this, meld it into previous commit. Use this, meld it into this commit. Use this, meld it into this commit. And together they will be melded on this topmost commit. Okay. As I save the changes, oops. Okay. So it's asking you. Now here, there is another editor which is open, which is asking you commit message. Why are you squashing? Do you want to add any commit message? Any details you want to enter? You can enter over here. Press I, press insert or I to insert and add any more new commit IDs you want to add. And you will see here, squash is going to occur between these commit IDs. Okay, last 4 commands done. So let's go ahead and save this file. Okay. So please see, one file has been changed. All the changes are available. You can see now on the branch, the commit history. So can you see? I'll show you the previous commit history. So this was the previous commit history. We have picked this commit ID. From this, we took all the commits about to squash. Now see, we'll compare it on the node. To see this last commit remains as it is, F8 remains as it is, A3 remains as it is, F1 remains as it is, A3. So this is where we started. Okay, this is where we started. From here, all the changes were squashed together into a single commit ID. So can you see? It got squashed into a single commit ID. Okay, everything is clean. It creates a new commit. You can execute a git show command. And you can see what happened inside it, that all the changes have been merged together. So that is your squash operation on Git. All right. Now let us look at one more operation before we close this part, which is stashing. Okay, we have completed git merge, git rebasing. Rebase command also helps you to perform the squash operation. A squashing is a technique that combines multiple commits into a single commit ID, which is used for merging or streamlining your commit history. It just makes your commit history more manageable. That's a squash operation. Okay. Now, we'll talk about fetch and pull in the remote repository section as I proceed. There's one more that I want to show you on the local repository, which is your stashing. So, for example, you are on a branch. Let's say we switch to the master branch. Okay. On the master branch, let us see if there are any changes. Everything is clear. So, let's say you create some modifications on a file. The available files are, let's say, file master. On this file, you do some changes. Add a new change. But let's say this change is incomplete. This change is incomplete. Okay. We added a new change and this change is incomplete. We still have to test it. Okay. But meanwhile, I got another task to work on an index file. Let's say I've modified the main file, which I'm currently working on. But I have to look into another issue, which is on the index1 file or maybe some testing issue. Right now, I cannot work on this. I cannot work on this file. I do not want to push the changes into the local repository. I don't want to commit these changes into the local repo because they are incomplete. They are not tested. So Git gives you an option that you can ignore these changes. Git can ignore these changes and will not push into the local repository by using the stash command. Stashing, so see the English meaning of stash. That is something that you save for future. Save some, this is stashed money, saved for future, right? So similarly, these are some changes on the file that I want to save for future. I want to work on it later on. So I don't want it on my working directory. I don't want it on my local repository. So we can stash it in the .git folder. How can we stash? Use the git stash. A git stash command will take the pending changes and stash them into a temporary location. Save the working directory changes into a temporary location. So you can see working tree is clean. You can do a cat of this file. See, nothing is there inside the file. It is empty. If you open the file, you can see the file will be empty. It's empty. So the changes, where did the changes go? So the changes are sitting in .git folder. If you will go into reference, if you will go into stash, inside this file, your changes are sitting. Okay. In this index number, your changes are sitting. Now you can see the stash via the command. I want to see where are my changes. So you can do a git stash list. A stash is a memory location which stores your data. And a stash always generates an index number, like an array. Okay. Like in Java, we have list of arrays. Every array is a memory location that stores some data. Stash is also an array which stores a data. So in this stash location, your data is present. You can execute the command git show stash @ 0th index. Git stash. Okay. Git stash show. Many revisions specify stash @ git show stash @0th index. This is the command which shows the stash. Git command stash. Git stash -- show. Okay. So let's look at this. Git show push patch quite all. All right. So we will look at that list. Git stash list shows you the list over here. And this is your stash number. However, if this command works, let us check the documentation for the Git to see the stash details. That is one thing. Now, if you don't want the stash, you want to get back the changes. Okay. Am I in the .git folder? One moment. Probably I'm in the .git folder. Let me go back here. No, sure I am. Okay. All right, I'll check this command to see the stash content. However, once the stash has been created and your changes are no longer there in the working directory. Now, let's say you want to work on these changes. Then you can execute the command git git stash pop. So it will pop the stash and the changes will be back to your working directory. Git stash pop is a command which will drop the stash and it will be available into your working directory. Git stash is a command which will stash your changes on the .git folder. So this is the command. Okay, git stash list will list the stashes that we have created. If you want to see the stash, it is the git stash show command only. But right now it isn't working. Probably it is on the Windows server, but on the Linux machine, it does work. We'll check that. Okay. However, if you don't want the stash, you want to bring back the changes to the working directory, git stash apply command can be used. And apply command will not delete the stash, but will bring back the changes to the working directory. Your changes are back to the working directory. Your stash is also available. However, if we say git stash drop, pop, the git stash pop, it deletes the stash and brings back the changes also. Okay. Now, if you see a git stash help, okay, see here on the git stash help, git stash list will list the changes. Git stash show is there. Okay. Git stash show minus you include untracked, or let's just use git stash show. So it will show you the file that it has stashed. Okay. It will show you the file that it has stashed. Just give git stash show. It will show what we have stashed in. No need to give stash at the rate 0th index, not required. Okay. Then git stash drop. It will drop the given stash. Okay. All the stashes. Pop will delete and bring back the changes. Okay. Stash on a given branch. Push or patch here it goes in an interactive mode. Clear the stash, remove the stash, git stash, because we have already added the changes to the working directory. You can clear it. Okay. Spelling mistake. Clear. Okay. I don't have any stash now. Okay. However, the changes I have already applied them to my working directory using the git stash apply. All right. So that's your git stash command. And we will stop our part 2 of the DevOps interviews over here. I really hope you thoroughly liked this part 2 of DevOps interview questions and answers, and you found it useful and insightful for your upcoming interviews. We are preparing the next round of questions for you. So don't forget to subscribe our channel. Stay tuned and I'll see you soon. Thank you so much, everyone. Bye-bye.